Hello everyone, welcome to my channel. In this tutorial, we learn about MCP and how we can implement a simple MCP server using Spring AI. So let's begin. MCP stands for Model Context Protocol. Here, model refers to the AI model, more specifically, Large Language Model or LLM. Regarding context, this is the additional contextual information that you can provide to LLM. For example, we can provide contextual information by accessing local file system or by running queries from a database or executing any external tools. And MCP is not a framework, it's not a library, it's a protocol with client-server model. Let's quickly check the high-level architecture of MCP. There is a host application like Cloud Desktop. The host application will use several LLM, of course. Inside the host application, we can create multiple MCP clients that can connect to different MCP servers. Each MCP server can serve a specific purpose. For example, one MCP server can provide access to the file system, another can provide access to the database, another can call external API, so on and so forth. Each client will have a one-to-one connection to a single MCP server. Let's first do a quick demo on how to develop a MCP server using Spring AI and how it can be used from Cloud Desktop. For this demo, we'll use Cloud Desktop. Cloud is LLM application developed by Anthropic. We know LLM usually have a knowledge cutoff date. I had a previous chat in Cloud Desktop. You can see the knowledge cutoff date is in the beginning of this year. That means LLM does not have the most recent information. For example, LLM will not be able to provide latest weather information with regular setup. Now, most LLM application can use web search as additional context. And using web search, this problem can be solved. But suppose we want to fetch the latest weather information from a custom source. MCP server can help us in this regard. Now, without web search, if we ask Cloud application to fetch the latest weather alert of New York City, it won't be able to tell it. Let's see how it goes. So it's telling that it does not have the access to the latest weather information and it cannot tell the weather data. Now let's make a MCP server of our own and add it as a connector for Cloud. We will develop our MCP server using Spring AI. The project will be quite similar to any regular Spring Boot project. I have already made one project. Let me explain what I have done so far. Let's start with the POM XML file. As the dependency management, we have used Spring AI BOM. And as the main dependency, we have used Spring AI Starter MCP server. This will be the main dependency for developing the MCP server. For remote part, we also need to add the WebMVC dependency. Now let's go to the main class MCP application. This is just a regular Spring Boot application class. And we basically developed one weather service. And we have used the API, root API, api.weather.gov. And this one is a free weather API developed by government of United States. The weather API has many endpoints and we have used two of them. One API is used to get a weather forecast for a specific latitude and longitude. And we have used another endpoint for fetching the weather alerts of a state of USA. And as input, it takes a 2-letter US state code. Here, the weather API is called using this client. Then the output is formatted to a certain response format. And then we converted this method to a MCP tool. To convert a method as a MCP tool, we need to use two annotations. One is @tool, another is @tool. tool param, and we need to provide proper description. This part is important because LLM will use those description to process the context. Now, to run it as a MCP server with STDIO transport mode, we need to make some configuration changes. Let's explore the configuration changes. I have created a separate spin profile for STDIO transport mode. Let's explore it. First of all, the Spring main banner mode, it should be off. Then web application type should be none. Then AI MCP server STDIO, it should be enabled. Then the logging pattern console, it should be empty. So one point to remember here, this logging pattern console, it should be empty, and this banner mode should be off. These two are quite important, otherwise it will not work properly with STDIO mode. So now let's build the project with the command maven command like this. So it will generate a jar file, and we can try to run it with regular Java command like this. But MCP server is not executed with STDIO mode in this way. We need to add it as a connector in the MCP host application. So let's see how to add it as a connector in the host application. From the setting menus, developer setting, there is a button edit config. If we click it, it will show us a configuration file. We need to add our MCP server in this configuration file. Let's see how to add it. So we need to add it as a Java command like this. So the main command is Java, and we have provided 3 arguments. One is the profile name, another is jar, and another is the path of jar. Claude has been restarted. Now if we go to setting again and open the developer section, and now we can see our MCP server has been registered and it is in running state. That's cool. Now if we go back to our chat and if we now ask for the weather alert of university again, let's see how it works now. So now it is asking for a permission to access these like MCP tool. So this will be the request, and if we now allow the MCP tool, so now it will call the MCP server internally, and then it will get the response, and then it will generate the response based on the contextual information that will found from MCP server. So yeah, we have got the weather alert now. We have seen a practical example of MCP server. Now let's try to understand how it works internally. Here is the life cycle diagram of model context protocol. There are 3 phases: initialization phase, operation phase, and shutdown phase. In the initialization phase, protocol version agreement and capability negotiation are done between client and server. In the initialization phase, the workflow is like client sends initialize request, then server sends initialize response, and finally client sends initialized notification. In the operation phase, normal protocol communication is done. There can be many type of protocol communication, like client can request for the list of MCP tools. Server sends the response. Client can request to execute a MCP tool. Server will execute the MCP tool and send the response. And in the shutdown phase, graceful termination of the connection is done. Usually the client cleanly terminates the protocol connection. All messages in MCP must follow the JSON RPC specification. JSON RPC is a stateless, lightweight, remote procedure call protocol. The protocol defines three types of messages: request, response, and notification. Request should be sent from client to server. The request message should contain the protocol version, the name of the method being invoked, parameters, and a unique identifier to match the response. The response message should be sent from server to client. The response message should contain the result, the ID, the same ID from the request to match the response, and error part is optional. Error should be there only if there is any error or failure. The notification message should be sent from either client or server, but they should not contain any response. And in the notification message, there should be the protocol version, the method name, and parameters. Now let's explore the log file and find out some example of JSON RPC messages. Here, if you see the log file, it is working in STDIO transport mode, and it has received the initialize message, and then it received initialized notification. It also received one request for getting the list of tools, and it has got another request for getting for calling a tool. So yeah, that can give you the idea how the protocol works internally. So far we have worked with a local MCP server. How about if we want to deploy the server remotely? The service implementation will remain the same. We have to make some adjustment in the configuration file. So let's see what change we need to make in the configuration file. As of in the STDIO, the banner mode of this is no longer required. The logging pattern console empty, this is also not required. And the STDIO mode should be made false. We can mention the server port here. And optionally, we can also mention two endpoints, ACC endpoint and ACC message endpoint. But if we don't mention those, the default values will be used. So, and in the production environment, we usually deploy using container image or Docker image. So I have followed the same convention. I have created a Docker file, and it is a regular Spring Boot application Docker file. So nothing new. And the Docker compose file will use we build the Docker file and execute it in 8080 port. So now if we use the command docker compose up, then the service will start. Okay, it's starting. As the MCP client, we'll use MCP Inspector this time. MCP Inspector is an interactive developer tool for testing and debugging. As a prerequisite, Node.js should be installed in the system, and we can run the inspector using npx command. So Node is installed in the system, and to run the inspector, we need to use the npx command. So this is the npx command, npx@model context protocol /inspector, and we can provide some commands there, but we will not directly now. And it will open a browser window. This is the web interface of MCP inspector. We need to choose the transport type. This should be SSE. And we need to provide the server URL. It should be localhost 8080 with SSE. And using the connect button, we can connect to the server. Okay, server is connected, and we have also seen the initialize command here. So this was the request, and then this was the response. So from this web interface, we can see the list of tools. So yeah, so this is the list of tools. There are two tools listed, get alerts and get weather forecast by location. We can even call any tool, like if we mention the state and run the tool, it will run the tool, and this is the response. And in the history section, we can see all the calls, like it was calling the list of tools, and it also made a request to call a specific tool. So yeah, this is a good tool for debugging and testing. We can disconnect the session from here. One point to note, use of SSE or server sent event is suggested in the older version of model context protocol. In the latest version of protocol, use of streamable HTTP has been suggested. In Spring AI, the streamable HTTP approach has not been implemented yet. Thus, we demonstrated the SSE approach. That's it for this part of the tutorial. Hope you like it. In the next part, we'll cover the transport modes, SSE and streamable HTTP in greater details. Thank you. See you in the next tutorial.